Welcome back to a going to pour rain for 3 days day in Thailand. Today, I thought I would go back and look at my lead acid batteries because I'm only getting about half of the original range on the bike from when I bought it a year and a half ago. It would do 60 kilometers when I first got it, which is about 40 miles. I'm down to 30 kilometers on a good day. And that's tough because just to, make a run back and forth to the bulk grocery store and then down for a pub quiz and then down to the mall for dinner, that's my entire battery pack is shot. So I thought I would first buy some more of these. These are insanely expensive on the market. Even here in Thailand, these deep cycle lead acid batteries, I can find drop-in replacements for these, no problem, but they are something like, I want to say about 2,000 baht each, which is about $70, and I need 5 of them. So I'm not going to throw this thing away. So I thought, all right, let me have a look and see what's going on, see if I can breathe some more life back into them. Now these are called sealed lead acid batteries because this tab is literally glued on across and you're not normally able to open it up like a car battery. So I had to pry this off and break all the little bits of glue that were holding it in place. Then inside we see 6 individual cells and each one has a little rubber cap to hold it on. Now if we look inside the cell, I don't know how good the lighting's going to be on this, but it looks bone dry down inside. And what I'll do is I'll stick this little screwdriver in, tappy tap tap. You can hear it hitting the top of the plate inside, and that's just dry. And that's inhibiting the chemical reaction that is the life of how this battery does its job. So I went to the store today and to a special battery shop, which are a surprising number of battery shops in my little town, car batteries, and I got, this is special water for batteries. I'm assuming it's distilled water. It might have a tiny bit of sulfuric acid or hydrochloric acid in it to re-trigger the reaction. But I'm going to top up all of the cells in this one and then the other 4 batteries in the pack right there. And then we'll get it back on the road and see how our range works out. Now, to give us some perspective, back in the day, lead acid batteries were a pretty neat thing. It's basically the only battery technology that was worth a damn for about 100 years. They were super heavy and they consumed the liquid inside as part of the chemical process and gave off hydrogen gas, which is never a good thing, Mr. Hindenburg. But so rewatering batteries was a thing. And I remember when I built my electric Porsche back in 2009, 2010, I had massive lead acid deep cycle marine batteries. And I was every month or so, I had it in my calendar to check and rewater the batteries with distilled water. So the fact that these batteries are also lead acid, but they're sealed, which you think would make them a non-maintenance item, but physics doesn't work that way. There's still liquid in here, chemical reactions still take place, and the fact that these little rubber caps are on top here signifies to me that they're designed to let gas escape while keeping the liquid mostly inside in case it gets flipped on its side or something. So in reality, rewatering these things is an issue, and let's take a look at how we can do that. Okay, so I got a coffee cup and I put some of the water in it so I can have easy access, and I've got this little squeezy bottle. You don't know what this used to be used for. And I'm going to suck some of the liquid up, and then we're going to put it into the battery. I gotta figure out a better way to get that in without spilling everywhere. And you want to put just the right amount in here. You don't want too much. You just want it covering the plates, usually up to the bottom level of the plastic filler. So I'm going to put some in, check it, and top them off until all the cells are happy. And then come back and do all 5. Okay, as expected, all 5 cells were bone dry. Popped the covers off, took off the rubber caps, topped them up, and we used about this much of the bottle. I suspect it's about a quarter to a third, 250 to 300 milliliters. Less than I was expecting, but I'm going to wait a day or so and let this soak in. I noticed down the hole that there looked to be some kind of white material. I don't know if it's a kind of a hybrid AGM, absorbent glass mat, or something inside here, but I'm going to give it some time to soak in, top them up, and then see how we go from there. But I've got lots more for the next top up, and I marked all of the tops June of 2018. This is when it came from the factory, the 17th of December 2559 Buddha time, which is, this is 61, so it's a year and a half ago. That makes sense. We're 2661 now, or 2018 as parts of the Western world like to speak. So, more to do on the bike. I bought some cool new parts when I was up in Bangkok, including a new LED rear tail light. So that'll be part of my next project plan. Okay, it's the next morning and I checked all the batteries and they were bone dry. So I've refilled them and I've completely used the rest of that 1 liter bottle. The trick I found is if you just dribble the water in, there's trapped air which prevents the water from going down. It doesn't drain nicely into the cells. But if I push it in under pressure with the bulb, I can see air bubbles coming up from other ones. So there's some kind of loose interconnection between the cells. And I keep squeezing and I go down one side and back the other side. I keep squeezing until I can see water coming up with no air in it. And then I stop. And that's when I use the entire bottle for the 5 cells. So it looks like the first time I put the water in might have started, like a sponge effect, and it opened it up, and then now it's really sucking in the water. So I'll check them again tomorrow morning or later today and see how they look. But lesson learned, keep these puppies watered, and you have to fill them under pressure, or maybe with a hypodermic needle or some other kind of solution that avoids the air being trapped underneath. Okay, it's the next morning. The rain has failed to arrive, despite the weather app screaming at me. And the second wetting of the cells is complete, and we are not getting any more soaking in of the distilled water. So I think the batteries are happy. So what I'm going to do is just tidy these up, make sure the fill level in each cell is good, put the little rubber caps back on, and tappy tap tap this little plastic case back over. I'll put the pack back together and then I'll charge it. I can charge it in my room, no problem. And I'm going to watch the voltage on each cell. I've got a thermal camera where I can check the temperature and make sure something's not about to explode and catch fire. And then that's hopefully the last step before we start riding again. All right, we're about to do the first charge on the newly rewired and repackaged, flooded, happy, wet batteries. And instead of using my Chinesium charger, which is dumb and the other one burnt up on me, I thought I would use my new Cycle Satiator Super McDuper charger. I initially bought it for the lithium cells that I will eventually have, but this guy does lithium, lead acid, nickel cadmium and nickel metal hydride batteries, and it has all these built-in profiles for each battery type and each voltage step that are common. You can modify the existing ones, or you can make up your own new one, but I'm going to go with the 60 volt sealed lead acid pack profile that it's got already set up in there. And right now it's just waiting for me to plug in the pack. It's got kind of a crazy connector system. Cord comes out of there into this thing that you normally see in audio, 3 pins, but it's beautifully machined. Comes to a little stubby connector with these small Anderson connectors. I had to make up a little jumper cable with Anderson connectors to alligator clips so I can clip into the big Anderson connector that goes to the bike. And I've also got my meter connected across the pack, so we'll see what happens. Okay, it recognizes that there's a battery. It's sitting at 63. It's ramping up the output voltage and ramping up the current. It's a 5 volt maximum output. Oh, I'm going to have to move where I've got this plugged in because it's on a circuit for my uninterruptible power supply, which is really unhappy right now because it's probably pulling 500 watts AC out of the wall. It's 331 watts right now, yeah. Okay, let me move this to another circuit. All right, we're in my non-UPS protected circuit. Focus, we're up to 66.4 volts at 5 amps. We've been charging for 3 minutes. Total of 17 watt hours or 0.26 amp hours. I really like how that manages that for me. The meter says 66.3. The charger says 66.4. I'm happy with that. And I've got this thermal laser temperature measurement. So let's just take a look. Let's go to science. We'll just take a look and see if anything's unhappy with temperature. Looking for hot spots, especially on the connectors. If you have a loose connector, that's where the temperature problems generally happen in a battery pack. No, so everything looks good. The charger's happy, the meter's happy, the pack is happy. So let's check back in a little while and we'll watch the profile go up. It's charging to 72 volts, 330 watts going in right now. Looking good. Okay, the meter says we're at 72 volts. The charger says we're at 72 volts. And we are approaching full charge. So it's starting to back off on the current. We're down to 4.5 amps. We've been charging for a little over an hour, and we've put in 300 focus and 61 watt hours. I didn't know what the state of charge is, but this is a 1,000 watt hour. Yes, a 1 kilowatt hour pack. Nominal. I don't trust it, but that's what we put in, 362 watt hours, and the charger is starting to back off, and everything is good. All the cells are good. There's no bubbling, there's no heat, everything is great. But I'll tell you what, this charger gets hot. Let me just bring it back to life again for a second. But this is hot. I mean, that is hot to the touch. I wouldn't want to keep my hand on that for more than a couple of seconds. And up here it's self-reporting 56 degrees Celsius internal temperature. And my thermal imager, science, 48 degrees on the case. And the manual says it actually degrades the power output when it reaches 50 degrees Celsius. So I don't know if that's what's happening right now, that we're degrading the current a little bit, but we are at 72 volts, which is our target voltage. But I'll let it go for a little while longer and see what happens if we continue with a lower current as we reach the top of the current curve. Oh, curiouser and curiouser. As we were getting near the end of the charge cycle, I heard a kind of a popping sound, and I ran over and unplugged the charger, and we've got a little bit of water that is trying desperately to get out of the battery. That one's even bubbling a little bit now. So I'm going to take the caps off and see what the state is. I probably overwatered them. That's my fault. But let's take a look. Okay, I popped the top off of this one, and it immediately shot off a couple of the little rubber caps, releasing the gas and a little spray of sulfuric acid everywhere. So we have learned something. Not sure what my conclusion is yet, other than too much water. But let me examine the rest of the cells. Okay, all of the plastic lids are off, all of the caps have been taken off each cell, and quite a few of them had some pressure, and they were puffed up, or when I took the plastic off, the cap shot off all on its own. So we're going to complete this charge cycle like this, so the cells are exposed. Now, look at that on the charger. This is giving us the graph of its charging cycle, what it's done so far. You can see we were at 72 volts and the current was starting to come down from 5. So we were definitely on the drop-off part of the lead acid charge cycle when the unpleasantness happened. So let me plug this back in and we'll see if we can get to the end of the charge cycle again. And people think lithium batteries are tricky. Come on. Alright, I've started a new charge cycle, and it's already up to 72 volts at 3.8 amps. It went up there rather quickly, and now it's dropping down. It's pretty much picking up where it left off, but all the numbers are reset. The pack's at 72 volts, the charger's at 72. And no objections from the cells yet. It's just quietly storing energy and making hydrogen. And a little bit longer down the road, focus, we're down to 2.3, 2.4 amps 9 minutes later. And I had a couple of cells that were bubbling up water here and here, but I used some tissue as a makeshift sponge, rolled it up and stuck it down and drew away the excess water, and they both seem to be happy now. All the cells are good, no water coming out, and we're putting in only 160 watts into the pack right now. 0.4 of an amp hour out of 1,000. So we're pretty much into the charge cycle. Oh, calibrating. Interesting. Haven't seen that before. Self-calibrating, and then it goes back to charging. That's cool. Oh, look at that. We have a new unhappy camper. I'll have to take care of him. But I think we pretty much reached the end of the cycle. The voltage is dropping down. The amps are dropping down. Wow, it's up, it's down, it's all over the place. But I'll let it finish on its own. And we have charge complete. At the end, the charger was pulsing up and down. It would go from 0 to about 1.5 amps and then drop back down. And it ramped up and down and up and down. And I think what it was doing was sampling in what it calls, you find it in the manual, in what it calls the top-up time, this graph right here, where it's full volts across the top and then it drops down to charge complete. I think that's what it was doing, because it says the charger will hold the full voltage until either the current drops below complete amps or it has been held at the full voltage for top-up time. So top-up time is defined here as 4 hours, unless it's different in the profile, so I don't think that happened. So it must be that the current dropped below complete amps, and I'm pretty sure that's what happened. We had a little bit of bubbling from a couple more of the cells, but I cleaned that up. The pack is now slowly dropping down to its rated level of about 60 volts, a little over 60 volts. So tomorrow morning I'll button this all up and get back out on the road and see how far I can go. Okay, the battery is in the bike and it's showing 100%, but we're at rest right now. What really shows the pack, how the pack is doing, is when it's under full load. Right now I would expect with a freshly charged battery, this is going to stay right at 100. After about 30 kilometers I'm down to 50, and then it drops off quite dramatically after that. So hold on to your hats, because this is what happens under full load. We are now at showing 10%, and I've just eased off the throttle again to make this turn. Come around on the throttle, 10%. These batteries are hosed. Okay, as you can see, under full load, a freshly charged battery with freshly rewatered cells goes down to 10% of available power instantly. It appears I've completely boned my battery pack, and I am very unhappy. I thought this was a thing, but apparently I've destroyed my batteries. Now, what I did is I just parked the bike, and I've been riding my good old Honda Click for a little while. I'm just going to let the bike sit there so that I don't get angry and start smashing things. And I'm starting to work on the lithium cells that have arrived from China. So I think that'll be the end of the road for those lead acid cells. Even though they should be all nice and wet and happy, they are not. So I'm going to wrap up this little tale, this little cautionary tale, and point out to you that maybe you can't rewater your sealed lead acid batteries despite all the other YouTube videos showing you that it can be done. So I'm just going to go meditate for a little while so I don't smash things. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.